Hi everyone, welcome to day 12. So today we're going to be dealing with probability with Venn diagrams. This is going to be very similar to day 11 when we guys went into introduction to Venn diagrams, but today we'll be mainly focusing on this notation and we'll get into more and what these symbols mean. We'll get more into it in the lesson to come. So just grab your pencil, grab your notebook, and let's take some nice notes. So for our warm-up today, we're going to fill in this Venn diagram here. So a survey was taken, and it was how many people owned cats, dogs, both dogs and cats, or neither a dog nor a cat. Okay, so again, with these types of problems like Venn diagrams, you're going to want to work from the inside out. And what I mean by that was work from the inside of the Venn diagram out. So this area right here, the both. So if you look up here, it says that 20 have both. So I'm going to put 20 in there. So we have 20 who have both. Next step, this next part, it doesn't matter. You're going to be working outside, so we're going to be moving into this region. But it doesn't matter which side you do first. So it doesn't matter if you do dogs then cats first or cats then dogs. So if we're doing cats first, we know it says 25 people have cats. So I'll do 25 here. But that 25, this 20 here, is included. It counts for that 25. So to kind of get rid of that double counting, we're going to subtract that number that's in the middle there. And so you're left with 5 people who just have only cats, no dogs. Now we'll fill out the number of people who have dogs. Okay, so we have 30 people have dogs, but again, we're doing that same step where we're subtracting that 20 to get rid of the repeats, the double counting, I should say. And then we're left with just 10 people who have just cats. Okay, and then it says 25 have neither. And neither is this space that's outside of the circle, but still within the box. So I'll just put 25 here. So we have that completed now, but now it's asking us how many total people took the survey. So to do that, we're just going to add up all the numbers that we just filled in. So we'll have the 5 people who have just cats, plus the 20 people who have both dogs and cats, plus the 10 people who have just dogs, and plus the 25 who had neither a dog nor a cat. And that's going to get you to, let's see, so that's 30, 35, 60. 60 people total took that survey. So feel free to pause, rewind, or move at your own pace. So now this is going to be very similar to yesterday. This same exact page was in your notes. So feel free, if you didn't get this stuff written down, you might want to copy that down real quick. Again, feel free to pause it. I'm going to keep moving forward. And our notation here, this is what I was talking about. This stuff is the part that's different from what you guys did in day 11. So it's really the 3 new things you're being introduced to are these 3 different symbols. So this symbol that kind of looks like an arch represents and. So you've seen and before. So it's when it's asking like the probability of A and B happening. You're going to see it in the form of like probability of A and B. So that's kind of what it's going to look like. Oh, see down here for in these examples down here. And the way I like to remember this symbol meaning and, meaning they both occur at the same time, I like to think of it as if you drew a little like mark across, it looks like an A. So I like to think the arch means and vice versa with this U shape that represents the union. So that's another word meaning or. So that's when all the items which appear in set A or in B or in both. So that includes this or, includes that and. So that's how I like to differentiate. Remember how and looks like an A and or looks like a U. Last but not least, we have this little apostrophe here. The apostrophe is the same thing. Remember how, let's say, it says a complement. So you remember how that means everything that's not within the set A, but that's equivalent to that little like apostrophe. So that denotes the complement of the set. That refers back to a couple days in the past. So this marking is the same as that C. So if you see this, know it means complement. Okay, now we can get some practice with it. So probability of rolling an even number if you have a 6-sided die. Let's see, so we know that the even ones are going to be 2, 4, and 6. Remember how we do the probability? We take that total number of outcomes, which is 6, because 1 through 6, that's 6 different numbers. And 3 of them are even, which is equivalent to 1/2, which is the same thing as 0.5, or 50%. Now, probability of rolling an odd number, our odd numbers in this set are 1, 3, and 5. Again, we're going to have the same denominator, but instead we're still having 3 because there's 3 odd numbers, which is equivalent, again, reducing to 1/2, 0.5. Now for number 3, this is where we get that notation that we just learned up above. So probability of an even or, this means or. Remember, it matches this one up here. So that's or. Probability of even or an odd. Okay, let's go through and underline all of our even numbers and all of our odds. So if we do our even ones, we have 2, 4, 6. Now our odd numbers are 1, 3, and 5. So what's our probability? So if we have, there's 6 total outcomes, and 6 of them were either odd or even. So that is just 1 or 100%. Now for number 4, we have probability of even. And remember, this is and, kind of looks like an A. And odd. Okay, so let's see. Are any numbers, can a number be odd and even at the same time? The answer in this set here is no. There's no number that's odd and even at the same time. So that's just going to be 0%. Now the probability of getting an even, or, remember that means or a 5. So our probability of even, we said, was 0.5. Or, sorry, I'll do 3/6. So we have 3/6. Here, I'll go. So our even, I'll underline, we have 2, 4, 6, or 5. What's our probability of getting a 5? We add, so we have it's out of 6. Then we add that 1/6, and that gets us to 4/6. Again, another way you can look at it is see that we underlined 4 numbers out of the 6 up here, which is equivalent to 2/3, or about 0.6 repeating. Now we have number 6, probability of even, and remember this means and 5. You can look at it and think, which, if even, so 2, 4, 6, 5 is not included within that even. So a 5 is an odd number, so a 5 cannot be even. So we know that's just 0% because that can't even occur. Now we'll get some practice here. So if there's 220 BHS student attendance of the first football game, 200